Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Saroke Institute of Engineering and Technology, Kolhapur. Today we are going to start our unit number 4, that is air compressor. Air compressor chapter consists of 8 marks. This chapter is very simple chapter and has the lowest weightage out of all 5 chapters. This chapter will be completed in preceding 2 sessions. The learning objectives for today's session are: number 1, study of air compressor, its types and the terms related to it. What do you mean by air compressor, its application, its various types or classification, and terms related to it will be studied in today's session. Second, study of single acting reciprocating air compressor. The constructional details and working of a single acting reciprocating air compressor will be studied in today's session. Starting with first, air compressor. Air compressor is a machine which sucks low pressure, low temperature air from atmosphere and compresses it to high pressure, high temperature by reciprocating motion of a piston or by rotary motion of a blades in a casing. It is work absorbing machine driven by external source. The air compressor is nothing but a device which sucks air or low pressure, low temperature air from atmosphere and converts it into high pressure and high temperature using external device by means of reciprocating piston or by means of reciprocating piston or by rotary motion. The compressed air can be used for n number of applications and which are generally used nowadays. Following are some applications of compressed air: for filling the air in tube of the vehicle, that is for filling the air in the tires or vehicles, in automobile service station to clean the vehicles, for spray painting in paint industries, in a vehicle to operate brakes. Some brakes operate over the air and are called as pneumatic brakes. For cleaning the workshop machineries, for cooling large building, for supercharging of an IC engine. We have seen for supercharging compressor is used to compress the air, for automation of fuel in diesel engine, for blast furnace in a factory, and for operation of a pneumatic tools like drills, vibrators, pneumatic guns, etc. The compressed air can be used. Air compressor is used in combination with all other. Particular main application of air compressor is for the tool handling and work surface cleaning in. Next point is classification of air compressor or types of air compressor. Air compressor are mainly classified into two types: reciprocating air compressor or rotary air compressor. Below figure shows how the compressors are classified into two types. The main two types: reciprocating, that is positive displacement compressor, and rotary type. In reciprocating type, they are again classified into two types: single state air compressor and multi-state air compressor, which are again classified into two types: single acting air compressor and double acting air compressor. We are going to see single acting and double acting reciprocating air compressor. Whereas the rotary compressor are classified into two types: positive displacement air compressor and non-positive displacement air compressor. Positive displacement compressor are the one which ensure the delivery of the air is continuous, whereas non-positive displacement are the delivery of air is intermittent. The positive displacement compressor are root type, vane type, screw type, whereas the non-positive displacement compressor are of centrifugal flow air compressor or axial flow air compressor. Air compressors are also classified as according to the capacity, that is low capacity, medium capacity and high capacity compressor. According to the pressure limit, low pressure compressor, high pressure compressor, medium pressure compressor, and according to the driving unit used to drive the compressor, that is direct drive compressor, belt drive compressor or chain drive compressor. So these are the classification of an air compressor. Before moving further, let us understand some terms related to the air compressor. The very first is compression ratio. Compression ratio is defined as ratio of volume of air before compression when piston is at BDC, that is bottom dead center position, to volume of air after compression, that is when piston is at TDC, top dead center position. It is denoted as RC and it is given as RC is equal to Vs plus Vc upon Vc, where Vc is clearance volume and Vs is swept volume. Compression ratio is defined as ratio of volume of air before compression to volume of air after compression. Next terms related to compressor are compressor capacity. Compressor capacity is the quantity of free air actually delivered by compressor in meter cube per minute. The quantity of air delivered by the compressor in meter cube per minute is called as compressor capacity. Third, free air delivery delivered, FAD, also known as FAD. FAD is or FAD is volume of air delivered under the condition of temperature and pressure existing at compressor intake, that is volume of air delivered at surrounding air temperature and pressure. Free air delivery is nothing but volume of air delivered at surrounding air temperature and pressure. The next terms related to air compressor are swept volume. The volume displaced or swept by the piston when the piston moves from top dead center to bottom dead center. It is also called as stroke volume and it is denoted by Vs. The volume displaced or swept by the piston when it moves between top dead center and bottom dead center is called as swept volume. Swept volume is given by area of piston into stroke length, that is Vs is equal to pi by 4 d square into L, where d is equal to diameter of piston and L is equal to stroke length. And the last is pressure ratio. Pressure ratio is the ratio of pressure of air after compression to before compression. Pressure ratio is ratio of pressure of air after compression to before compression. So these are the some terms related to air compressor. Starting with reciprocating air compressor. Reciprocating air compressor are called as positive displacement compressor because they displace a fixed amount of air, that is the discharge of air is constant. Below shows the figure. The principal part of reciprocating air compressor are shown in figure. These are same as that of an IC engine. The figure shows sectional view of an air-cooled single-stage, single-acting reciprocating air compressor. Both suction and delivery valve are disc type and are operated automatically. They are open and closed by difference in air pressure acting on their two sides and are kept closed by light springs. During the downward motion of an piston, the pressure inside the cylinder falls below atmospheric. Thus, the suction valve gets open and atmospheric air enters into cylinder. During the upward motion, that is during compression stroke of piston, the air inside the cylinder is compressed, which increases the pressure than the reservoir pressure, which causes the resistance on the spring to open the delivery valve and discharge takes place from cylinder to receiver. The receiver is a closed vessel and acts as a storage tank. The compressor is driven by external source. Sometimes it may be electric motor, sometimes it may be power prime mover, sometimes it may be IC engine. The prime mover will have to supply very high starting torque. To avoid this, hand unloader is used for releasing pressure from compressor cylinder when the compressor is stopped. So this is how the single acting reciprocating air compressor works. Single acting reciprocating air compressor as shown in figure are always vertical. The piston is directly driven by connecting rod and crankshaft enclosed in crankcase, which is pressure tight. There is only one delivery for high pressure air for every revolution of crankshaft. It requires less floor space for their installation. The power or the air obtained is low as compared to double acting reciprocating air compressor. Double acting reciprocating air compressor as shown in figure are always horizontal. Two deliveries from both sides of piston for each revolution or of crankshaft can be obtained in double acting reciprocating air compressor. This compressor requires more space as compared to single acting vertical compressor. Both sides of piston are exposed to rapid change in temperature and pressure. There is chance of leakage in this type of compressor. Large stuffing box is used to prevent the leakage. This is a heavier in size and requires lot of maintenance and proper handling. So this is it for today's session. Today's session we have completed at the first point of an fourth chapter, air compressor. What do you mean by air compressor? Its application, types of air compressor, single acting and double acting reciprocating air compressor. Thank you.